Howdy y'all, today's lesson is on linear inequalities. Linear inequalities are really similar to linear equations, except now we get to color one side of the graph. So let's go ahead and get started. So a linear inequality is the same as a linear equation, except with an inequality symbol. The solution to a linear inequality is going to be all ordered pairs that make the inequality true. So when we get to shading a certain side of the graph, the solutions to the linear inequality will lie in the shaded area. The shaded area will represent all solutions to that linear inequality, because you're going to have multiple answers here. Like for example, if let's just use a real simple line like that would have a zero slope, and the only answer there would be y is 6. However, if we had an inequality that was y is greater than 6, your answer could be 7, it could be 8, it could be 100, it could be 1,000, it could be anything that's greater than 6, right? So for this, you'd only have like one solution, but now with inequalities, you're going to have multiple solutions. Okay, so we're going to just practice here. We're going to determine which ordered pairs are solutions to this linear inequality right here. So let's just look at this first one here. Let's look at 2, 5. So 2 is my x value, so let's plug in that 2 where the x goes. So 2 times 2, and then minus 3 times 5. And all of that needs to be less than 15 if 2, 5 is a solution here. So let's see if it is. So 4 minus 15 is less than 15. I think this is going to be a true situation here. So negative 11 is less than 15. And that's a true statement. So therefore that is a solution. So this is going to be yes. That is a true statement. Let's try, I'm going to do 0, 0 because that one's really easy. Zeros make your life much easier. So 2 times 0 minus 3 times 0, oops, it's supposed to be 0, is less than 15. So these go away, right? 0 minus 0, so is 0 less than 15? And we know the answer there is going to be yes. So you guys can test out those two on your own. Okay, so steps for graphing linear inequalities. So we need to write the inequality in y equals mx plus b form. And we know instead of this equal sign, we're going to have some sort of inequality sign. Okay, but we are going to continue with the slope-intercept form there. And then you're going to graph the inequality. So this is really important. If you've got a less than or greater than symbol, you are going to use a dashed line. A dashed line. And then if you have less than or equal to or greater than or equal to symbols, you need to use a solid line there. You need to use a solid line. And one way to remember that is if you look at these two symbols, they've got a solid line underneath them. So, I don't know, it's just a trick to help you remember that. And then you use a test point. So after you've graphed everything, you would use a test point to determine which side of the line to shade. I would recommend, so usually we're going to use the point 0, 0 because zeros they're really easy to work with. They cancel everything out. So 0, zeros is going to be the easiest. That's going to be the easiest point to work with. However, if your line falls on 0, 0, then you can't use that because you need to figure out which side of the line to shade. So let's practice that. It'll make more sense when we do a problem here. Okay, so number 1, we have y is greater than 1/3 x minus 5. Y is greater than 1/3 x minus 5. It's already in slope-intercept form, so let's move on. Let's go ahead and graph it. I know my y-intercept is negative 5, so go down to negative 5, plot a point. And then I'm going to be going, so my y-intercept is right here, and then I'm going to be going up 1 to the right 3 because I've got a slope of 1/3. So let's do that. Up 1 to the right 3, up 1 to the right 3. Make a couple points here. I'm going to make a couple in the other direction too because it's really hard for me to draw straight lines using this program and using this particular pen. So if you guys have a ruler, you only need a couple dots. You can make a perfectly straight line. And so Now I need to connect these dots, but instead of using a solid line, I've got a greater than symbol, so I'm going to use a dash line. So let's use a dash line to connect all these points. The dash line symbolizes that the solution cannot actually lie on that line, if you're curious why we use a dash. Okay, and so now comes the test point, the thing we were talking about in the first slide there. So with your test point, so if you notice, 0, 0 does not lie on this dash line. So I can use 0, 0 as a test point. That'll work just fine. So I'm going to test out to see if 0, 0 is a solution to my original inequality. So my original inequality, I'll rewrite it, 1/3 x minus 5. And then I'm going to see, is 0, 0 a solution to that inequality? Is it a solution? So is 0 greater than 1/3 times 0 minus 5? Let's see if that's true. Is 0 greater than -5? And that's going to be yes. That tells me that 0, 0 is a solution. Therefore, anything on this side of the line must be a solution to the inequality. Okay? So you notice I'm not really like shading it in, like coloring it in. I'm kind of using these lines like this. And that's because when we get to systems of inequalities, you're going to want to color it in like that. And that'll make more sense when we get to that lesson. But so here we can determine that 0, 0 is a solution, and so is anything in that shaded area. This inequality is going to have multiple solutions. Okay, let's look at another one. So again, this is already in slope-intercept form, so I'm good. Let's go ahead and start at -1. That's my y-intercept. And then my slope is -2. So if I were to make that into a fraction, it'd be -2/1. So that means I go down first and then always to the right, unless we run out of graph. So down 2 to the right 1, down 2 to the right 1. Again, I'm going to make just a few in the other direction so I can make my line as straight as possible here. And then I'm going to connect all these with a solid line. Solid line in this case, because I've got a less than or equal to. So the solution can lie anywhere on that line because I've got a solid line. Now comes our test point here. So my test point, if you can use 0, 0, always use 0, 0 because it's a lot easier. In this case, 0, 0 is right here. So it's just above that line, so I can use it. It's just to the right of that line. So let's go ahead and test out and see if 0, 0 is a solution to the inequality. So I'm going to rewrite it right down here and then plug in 0, 0. So is 0 less than or equal to -2 times 0 minus 1? Is 0 less than or equal to -1? That is a false statement. That is not true, right? 0 is not less than a negative number. It's not less than or equal to a negative number. So now in this case, I'm going to go away from 0, 0. So here's 0, 0 on the right side of the line. It just told me I'd use that test point, and it just proved that that's not a solution. Therefore, all the solutions must lie on the other side of that line. Okay, so now we've got one that's in standard form. So I've got a little bit more work to do here before I can start graphing this. So let's put this in slope-intercept form. So 2y is less than -3x. So all I did was subtract 3x there. Subtract the 3x. And then let's solve for y. So divide that by 2. You can add the 0 if you want. It really doesn't matter. Y is less than -3 halves x. And because I divided by a +2 there, guys, I don't need to flip my sign. But this is the same as inequalities. If I were to divide by a negative number, you would have to flip your sign, so be careful with that. So here's my new equation in slope-intercept form. To graph this, I'm going to start at 0, 0. So this is going to be a case where we can't use 0, 0 as a test point. So I'm going to show you what to do. And then you got to go down 3 to the right 2, down 3 to the right 2. Oops, I only went down 2 there. Need to erase that. Okay, let's see if I can figure out how to erase. There we go. And then I'm going to make a couple points in the other direction too. And then in this case, we've got a dashed line, right? Because I'm dealing with a less than symbol. So I'm going to use a dashed line to connect all these. So we'll go ahead and do that now. Dashed line, which means the solution to the inequality cannot actually fall on that line. Now here's one of our special cases, right? I can't use 0, 0, so that's a bummer. But I'm going to pick another really, really simple coordinate. I'm going to pick 1, 1. Ones are also really easy to deal with. So let's pick 1, 1, and let's see if that's a solution to this inequality. So again, you go to your original. You could go back to the original or you could go back to the revised, actually. It doesn't matter. I'm going to go back to the revised. And then I plug in 1. So 1 is less than negative 3 halves times 1, which is just negative 3 halves. That is a false statement. I know that 1 is not less than a negative number. So therefore, here's my point, 1, 1. I'm going to go the opposite direction. I just proved that that is not a solution to the inequality. Therefore, nothing on that side of the line would be a solution to that inequality. So I would shade it in to the left there. Okay, one of our special cases, so I thought I would do this one with you guys. We've got y is less than or equal to negative 4. So we know in this case we're going to start at negative 4, right? That's our y-intercept. And then we're going to have a 0 slope. So we're going to have a line that looks like this at negative 4. So actually these are fairly easy to graph if you know which way those go. So y is less than or equal to negative 4. And in this case we have a solid line because I've got 4 equal to. So the solution could be negative 4. It could be anywhere on this line, right? It could be 0, negative 4, it could be 1, negative 4, 3, negative 4, 10, negative 4. Anywhere on this line represents solutions, but let's figure out which side of the inequality we want to go on. I'm going to use 0, 0 as my test point. So let's test out 0, 0. Is 0, 0 a solution to this inequality? Let's figure that out. Is 0 less than or equal to negative 4? We know obviously that is not true. So we go away. So here's 0, 0. That's not a solution. So I'm going to shade in this direction here. Shade in this direction. And anything in that shaded area represents solutions to the inequality. Okay, that's actually it for the video. So you only have that back side there to finish. Go ahead and finish the gaps of those notes that we did not do together. And if you guys have questions, please ask. I know this is kind of a different concept, but really similar to linear equations. So as you go along, if you guys have questions, please ask. When you're done, go ahead and raise your hand and I'll check over your notes.